So any idea how you do this 1a? Gradient from a pair of coordinates.
Is x1 minus I can't really remember the formula, but it's x1 minus x2, is it? Over y1.
It's similar to that. So just to make sense of it, it's how many up over how many right. So from the first point, second point, how many up did it go? How many right did it go?
So it's gone 4 up and 2 right.
Yeah, and so the gradient is 4 over 2, and then you just simplify it. And so what is that?
Just 2.
Yep. Same thing, next one.
That's 3 over 5.
For B, is it?
B. B or D, sorry.
B.
Yeah, that is 3 over 5. And then.
Oh, you simplified it, did you?
3 over 5.
So how many up did it go?
3.
From 7 to 9?
Oh, so I was looking at 7 to 10 and 4 to 9 for some reason. 2, sorry.
And how many right?
6.
So gradient?
Should be 0.3 again.
Let's say a third.
Yeah.
Okay, C.
C just 1.
So this time it went 4 to the left, and so that's minus 4 on the bottom.
So minus 1.
Yeah. So now maybe it's a good time to use the formula. So the formula is always second y minus first y. So that gives you the difference in the y's. And then second x minus first x for the difference of the x's. So try that for D. So what are the values you're subbing in for D?
So it's 8 minus 2 and then 2 minus 2. So that's 2 plus 2.
Yeah.
It's just 6 over 4, which 1 and 2 quarters.
Yeah, 3 over 2. It's fine. Because basically that means 3 up and 2 right. So that's why we usually leave it as a fraction. Let me just see. Yeah. Let's try F. And you can always just put it into your calculator, like once you've written down the working out.
Yeah. So minus 7 minus 5 over minus 5 minus 4.
Yeah, and so you,
minus 12 over minus 9.
and so calculator simplifies it down to 4 over 3.
Yeah.
And so there you go. And let's say H, last one.
Minus 2 minus 6 over minus 7 minus 8.
Minus 7 minus 8. You just put in your calculator and it gets simplified. So any questions about that?
No, that's alright.
Okay, so that's how you get the gradient of a line segment between 2 points. So gradient of a part of a line between 2 points, difference in y's over difference in x's, and it's basically how many up over how many right. Okay, question 2. So the first one, what's the gradient? What's the intercept?
The gradient's 4, the intercept is minus 1.
That's fine. What about question C?
Gradient of minus 1 and an intercept of 6.
Yeah. How about 3A?
There's a gradient of minus 1 again and an intercept of minus 3.
Well done. So M is minus 1. So if it's not rearranged, you just rearrange it yourself. What about B?
Is it a gradient of 1 again and an intercept of 3?
So if you bring the 2y to the other side.
I brought the 2y and the minus 6 across. Do you need to divide them by 2? X minus 6.
Yeah.
So is a gradient a half and the intercept minus 3?
Yeah. So gradient is a half. And yeah, intercept's minus 3. So if it's not y equals, you just rearrange it to make it y equals. It's to make it y subject. Let's see. Yep. Okay, so you have to write down the equation of the line in this form. So not y equals mx plus c, but just the way they've written it. Y minus y1 equals mx minus x1. So all they did for that one, if we just go back. There we go. All they did was rearrange this formula. So y2 minus y1 over x2 minus x1, and that gives you m. That's equal to m. And if you multiply both sides by the x's, you get this. Y minus y1 equals m, x minus x1. So they don't say x2 and y2 because we'll just leave that as x. Okay, so try part A.
Can I just sub the values into the equation? Y minus.
So y minus
Y minus 1, sorry, equals 2.
Yeah.
And then x minus 4.
Minus 4. I think you're good there. Let's try F, last one.
Is that all I have to do for that?
Yep, that's it.
Perfect. Y minus y plus 7 equals minus 5 minus a fifth x minus x plus 3. Sorry.
Yeah, that's it. And yeah, technically they wanted the equation of a line. That's an equation because it's got an equal sign. It's got m, it's got x, and it's got y, and so that's the equation of a line. So they didn't, if they want you to rewrite it, you can. So here you can see question 5, they wanted it as y equals mx plus c. So okay, let's change the first one, a, into y equals mx plus c. What would you have to do?
Expand the bracket out to start with.
Yeah.
The 2x minus 8.
Mm-hmm.
And then float the minus 1 across, so it's plus 1.
Yeah.
So it's 2x minus 7. Y equals 2x minus 7.
That's it. So that's y equals mx plus c. And let's say the one on the bottom, let's write that as ax plus by plus c equals 0, where a, b, and c are integers. So basically no fractions.
Yeah. Could you say that again, sorry, please?
So make it so there's no fractions. So at the moment we've got minus a fifth.
Yeah. We're going to say times through by a fifth.
What gets rid of, what turns 1/5 into?
Plus fifth.
That would make it 1/25.
Oh, okay. I'm not sure.
Times by 5.
Right. Okay. So 5y plus 45 equals 5x plus 15.
No, I was afraid you were going to do that. Let's do it a different way. Expand the bracket first.
Right, okay. It's minus a fifth x.
Yeah.
Plus 3/5.
Yeah. Minus 3/5. And now multiply everything by 5.
Right. So that just becomes x, does it?
Minus x, yeah.
Minus 15/25.
That would be if you're multiplying by 5/5.
Is it just 15/5?
And what is 15/5? 15 divided by 5?
Just 3.
Yeah, and so it's just basically making it so it's not a fraction anymore. If you times by the denominator, it's not a fraction.
Yeah.
We wanted to make this equal to 0.
Okay. So then just float the minus x and the minus 3 across so that they become plus.
Mm-hmm.
And then it becomes 5y plus 35 plus 32 plus x.
Yeah. And no, not 32.
Oh, yeah, 38.
Plus 38 equals 0. Yeah, so sometimes they want it to be just integers, not fractions.
Yeah.
Expand the bracket and then multiply everything by the denominator. And they often want you to make it equal to 0. Equals 0. Any questions about that?
No, it seems alright.
Okay, and I'm sure we'll see. So there's question 6 saying the same thing. X plus by plus c equals 0. I'm sure we'll see another one later. Okay, question 7. They want the equation of the line for 2 points. How would you do that?
Can we find the gradient just how we have been?
Mm-hmm.
So we've got 13 minus 1.
Mm-hmm.
4 minus 0, so 12 over 4. So it's just 3. And then can you just sub in the value of y and the value of x?
Yep.
13 equals 3 times 1.
So let's put it into y minus y1 first.
So 12. Right, yeah. Is this how can we put it into this?
Sorry?
How can we put it into this?
So, because then we can just rearrange it to be y equals mx plus c.
Is this easier way?
I think so.
Yeah. So 13 minus 1.
No. It's y minus, and then you pick one of the y's.
Okay. Yeah. So y minus 13.
Okay.
Equals 3 times x minus 4.
That's it. And then you just rearrange that to be the y equals mx plus c. And I think it would have been much easier if you had picked the other point.
Yeah.
You get the same answer. And so what is it as y equals mx plus c? What do you do?
Oh, expand the bracket just to get 3x.
Yeah.
And then just float it. Yeah. Float the minus 1 across. So it's y equals 3x plus 1.
Yeah, that's it. So you can write it as, the y minus y1 equals mx minus x1, and then just use that. Okay, how about f?
Is it just the same way? So we've got 0.4 minus 4 and minus 2 plus 3.2.
That's it. So calculator says minus 3. I'm happy with that.
And then sub into the y minus y1.
Mm-hmm.
Just like I did before, so we've got y minus 4.
Mm-hmm.
equals -3 bracket minus 2 x minus 2 x plus 2.
If you chose 4, then you have to choose the matching x.
Right. All right. Okay. So minus 3.2.
Minus.
Plus 3.2.
Yeah. And then you just finish it. And I think you're okay for that part. Yeah. So if you choose you have the x and y have to be the two matching ones. So it doesn't matter which point you choose, so long as you choose the same two, the x and the y that go together. So minus 3.2 and 4, or minus 2 and 0.4. Any questions there?
No.
Okay. So 7. So this is similar, except they just want it as the not a fraction at the end. Okay. Let's try question 9. Someone's at my door. Just be a second. Sorry about that.
All right. So the equation. I'm just going to go with what we've just been doing again. So 2 minus 8 over 3 plus 6 which should equal minus 2/3.
That's it. Okay.
And then use the y minus y1 equals mx minus something. So y minus 2 equals minus 2/3 x minus 3.
X. Well done. And they didn't say they wanted it in any form, so that's now an equation of the line, so that's fine. And then how do you do part B?
Sub in the values.
Yeah, and there's kind of a special way to do it. If I was to bring the 2 over to minus 2, so just to make it y equals, so minus 2/3 x minus 3 plus 2. So they want you to sub in the x only and show that the y you get is minus 2. So the way you do it is you write y equals, all the stuff is the same except x is 9.
Okay.
And you should get minus 2. Therefore on the line. And in fact, like, you don't even need to check in your calculator. They told me that it's on the line, but I suppose just to, oops. Oh yeah, I can do answer actually for minus 2/3. 9 minus 3, and then that's plus 2, and you get minus 2.
Yeah.
So sub in the x and show that you get the y, and I think make it y equals just for that purpose. Any questions there?
No.
Okay.
Actually, yeah, there's just one.
Yeah.
If I take it, if we don't get minus 2, then it means it's not on the line.
Yeah, so our equation must be wrong.
Yeah.
Yeah, so either it's not on the line, and that was what they asked us, show that it's not on the line,
Yeah.
or oops, our equation must be wrong.
Mm.
Okay, let's do this one.
Should we rearrange the equation?
So let's try without rearranging it, because it doesn't say show or anything, it's just solve.
Right. Do you sub k in then?
Yeah.
What, x?
Mm-hmm.
So you get k minus 3y plus 15 equals 0.
Well, what is y?
2k.
Yeah.
I'll do sub that.
Yeah.
Right. I thought that. I don't know. I just thought that if we left it as it was, and we're trying to get 2k.
So we're not trying to show. We're actually trying to solve. Like, what is k?
Right. So 2 minus 3 minus 6k.
Yeah.
Plus 15.
Okay. Try to solve it.
Can you take? Is it putting into brackets? Is
No. K minus 6k.
Minus 5k.
Mm-hmm.
So minus 5k. That's easier. Equals 0. So 15 equals 5k. So k must equal 3.
Yeah. And I can solve it with my calculator. There we go. 3. So yeah, you sub in the x, sub in the y, and then solve. Any questions there?
No.
Okay. Let's see. Okay. Yeah, let's do 11.
we're subbing in again. So 8p minus 4p squared plus 5 equals 0.
Yeah.
And then that leaves us with a quadratic, doesn't it?
Yeah. And can you calculate solve quadratics?
No, I don't think so.
Just get one that does. Will you get one that does?
Yeah, I do need to before my exams.
So for this one, what is A, what is B, what is C?
A would be 4, B would be 8, and C would be 5.
Something's missing from the 4.
4p.
Minus 4.
Or minus 4.
Yeah. And so you get two answers, either 2.5 or minus 0.5. Yeah. So just let the calculator do the work on that one. Okay, how about 12? Right.
So if it's crossing the quadrant, what are the coordinate axes?
X-axis and Y-axis.
Oh, is that it?
Yeah.
So if it's crossing them, is that X going to be at 0 when it's crossing X, and Y going to be at 0 when it's crossing Y?
Yeah.
So do you just sub 0?
So sub 0 for X, find Y, and then sub 0 for Y, find X.
Yeah, so Y equals 5. And x equals minus 2.5.
And so when Y is 0, X equals minus 2.5. And what would those two be? They said find the coordinates.
So minus 2.5, 0.
And the first one?
0, 5.
Yeah. So they asked for coordinates, we gave them coordinates. All those are the same, including the very last one. Let X be 0, solve for Y. Let Y be 0, solve for X. How about question 13?
It's the same thing again.
Mm-hmm.
Sub 0 in for X and Y.
Yeah.
So sub it in to start of the year. If you sub it in for X, so X is 0, you get minus 18y minus 30 equals 0. So 18y equals minus 30. So minus 30 over 18 equals 1.
Yeah.
Is it minus 5/3
Yeah.
for y? And then, so you got 5x minus 5x minus 0 minus 30 for the next part.
Yeah.
So 5x must equal 30. So x is equal to 6.
Yeah. And what are the two coordinates for that one?
6 and minus 5/3.
No, it should be two different coordinates.
Oh yeah. So we've got 6 and 0.
Mm-hmm.
And 0 and minus 5/3.
0 and minus 5/3. Part B.
Find the area of triangle. I'm not sure.
So it really helps to do a sketch.
Yeah, sketch.
Okay, so we do a sketch. So we have to do triangle OAB. So these were points A and B. So one was 6, 0. One was minus 5/3. And O is just the origin.
Yeah.
And so we have to find the area of that triangle. How do we do
that? 6 times minus 5/3 divided by 2.
Correct.
Nice. So 6 times minus 5. But you can't have negative area, can you? So it's just 5.
Yeah. And what was it, sorry?
Just 5.
5. It's 5 square units. There we go. Great. Any questions about that?
Well, I can think of.
And that's a very common type of question where they throw that in at the end. Find the area of the triangle. So I'll just do a little sketch and then do that. Okay. Any idea how you do this one? The length of the line segment between them.
No.
It is basically, so if you were to do a sketch, it would be like the previous one we just did. From here to here, it's basically Pythagoras. So the length between the two of them is just.
Is that what it means by the line segment?
Yeah, a line segment.
Yeah.
So a line goes on forever, and then a line segment has a start and end. So it's only like part of a line.
Yeah. So I understand that.
So you're just doing Pythagoras, and so you've got 1 point, you've got another point. That one's 1, 1, and that one's 4, 5, and you have to find the length.
Okay.
And so how would you find the length of it?
So the dotted red line you just drawn would be 3.
Yeah.
And then going up it'd be 4. So 3 squared. 3 squared plus 4 squared square root. So it's 5.
That's it. So the length of that line is 5. So try B.
Do they have a special name of triangles? They're called the Pythagorean something.
Pythagorean triple.
Yeah.
Yeah, when they're all whole numbers. So hang on. So how did we get 3? I think we did x2 minus x1.
Yeah.
And then you squared that. And then you do plus the difference in the y's. And then you square the whole thing. Yeah, that's it. Okay, so try B.
So B. Let's go. 3 minus 0 squared. I'm just putting it into the formula. 3 minus 0 squared plus 1 minus 0 squared. And all that's square rooted.
Yeah.
You just slot that into the calculator.
Yeah.
We get 3 minus 0. I got root 10.
Yep. Root 10. Shall we just do the very last one?
Yeah.
Let's do the very last
one. Minus 7. Minus. Oh no, sorry. What I'm doing. Minus 2 minus 2 minus 2 plus 6, sorry. 2 plus 6 squared plus minus 7 minus 7 plus 3 plus 3 squared. Is it 4 root 5 the answer?
I'm sure it is. Minus 7 minus 3 4 root 5. There we go. Yeah. So it's basically just Pythagoras to find the length. Okay, how about this one? So this goes over to circles a bit.
Struggling a bit with this.
Sorry.
Struggling a bit with this.
How
My favourites are circles.
how do you find the radius of a circle, or what is the radius of a circle?
Y squared plus X.
Just in general, like radius of a circle.
What?
Like where is it? What is
it? From the centre of the circle to the edge.
Yeah.
Straight line.
So for this one, what's the center? What's the edge? So what?
Well, all the points lie on the circumference.
So is there one that we know that we can use?
Center. 2215.
So 2215. Do we know the center?
Is it in the top right?
Mm-hmm. Ah, you can't see it. Is that right? Sorry.
No worries. No, I was wondering that I would pick your brain. Seeing if it was anywhere on the screen. Yeah, center 2, 0.
Okay.
Perfect. Thank you. Yeah, that's fine.
And so you find the radius from that.
So radius. Is it 20?
Mm-hmm.
15.
Yeah.
Difference.
Might be a triple. There you go. Radius is 25.
Nice.
I believe. And then how do you do this possible values for K and C?
I'm not sure. I can't think.
You do Pythagoras, except instead of the 22 and 15, do it with minus 13 and C.
Right.
So from 2, 0, so that's center, to minus 13 C.
So it's what would it be? Minus 11.
Minus 13, minus 2.
Minus 15. So.
Yeah, basically they're 15 apart.
Yeah. Yeah, and then is it just C minus 0 minus C?
Yeah. Any idea what you do next?
Do you expand the minus 13 minus 2 bracket?
Yeah. So I think it's 225 minus 15 squared.
Yeah.
So we have to solve for C. How do we do that?
Is it all equal to 0?
This gives you the radius, doesn't it?
Right, yeah. So it's equal to 25 then.
Yeah.
Right. So can you square 25?
Yes, square both sides.
Yeah. And it gets rid of the square root. So 625. And then minus 225.
Mm-hmm.
Right, is 400. So C must equal 20.
So C is 20, technically 20 or minus 20, but it's just a radius, so it's 20. And then you would do the same thing for K. So what is it? You do the difference from 2, 0, which is the center, to the circumference, which is K, 24. You put that in the square root, make that equal to 25, and solve that one as well. Any questions there?
No, I think it's going to take a bit of practice, I think.
Yeah, and I think because there's lots of stuff, so that's why I just want to recap it. Okay, how do you find gradient of a line segment between 2 points?
Gradient is y2 minus y1 over x2 minus x1.
Yeah, and that just tells you how many up on the top, how many right on the bottom. So you're okay for this one. This one, yeah, just you're okay for that. Make y the subject. Yeah, if you rearrange that, m equals y2 minus y1 over x2 minus x1, you get this formula, and that's an equation of a line, and so you can just sub in your y, your m, your x, and that's an equation right away. If they want it as y equals mx plus c, just expand the bracket and make it y equals. If they want it as ax plus by plus c equals 0, where a, b, and c are integers, so basically no fractions, expand the bracket and then multiply by the denominator.
Yeah.
Expand bracket and then multiply everything by the denominator. Yeah. Let's see. How do you find the equation of a line between 2 points?
Between 2 points, you just solve for the gradient and then sub in the values.
Yeah.
To y.
Yeah, so you can sub it into this one and then just expand it and rearrange it to make it y equals.
Yeah.
Or whatever they want it to be.
Mm.
How do you show that a point lies on a line?
You sub in the x value and you should get the y value.
Yeah, and because of that, I just made it y equals, just so it's even clearer. And you can see how I didn't expand anything. Like I didn't expand the brackets and simplify. I just replaced x with the 9 and just wrote it exactly. That's my method mark. That's my accuracy mark. And I didn't even check in the calculator. If you have 10 minutes at the end, you could, but they told me it's on the line. Yeah, it's actually a good idea to check that it does work, because then you know your first equation is correct.
Yeah.
How do you solve for an unknown coordinate or whatever on a line?
For an unknown coordinate, you use the same method that we have been doing that.
Not quite. It's a bit different from the previous one. The previous one we'd sub in the x. For this one,
so we had to sub in both the k and the.
Yes, you sub in the x and the y.
Yeah.
Same with this one here. Sub in the x and the y, and then it is an equation. You know, it's equal to 0. It's equal to 15, whatever it might be. Where it crosses the axes, so that's when x is 0. Find y. Let y be 0. Find x, and don't forget that it's 2 different coordinates. So it's not the two together as one coordinate. It's 2 separate coordinates.
Yeah.
They very commonly will ask you, now find the area of the triangle. The way you do that is, it might help to do a sketch, but it's always going to be a half times base times height. So a half times the x1 times the y1.
Yeah.
But I think a sketch really helps. Yeah. How do you find the length of a line segment?
Pythagoras is there.
Yeah, it's Pythagoras. And then for circles, how do you find the radius of a circle?
So you look at the difference between the centre point and the a point that lies on the circumference.
Yeah, so it's basically Pythagoras again,
Yeah.
but just from the center to the circumference. And if you have to find an unknown point, same exact thing, Pythagoras, except this time you know the length, and so you have to solve to get like what coordinate would give you that length. How was that for you, Conall?
It was good, yeah.
So we got most of it. Triangles, corners. Just want to see.
I'm gonna say is there much more coordinate geometry, because when we were doing it in lesson, I found it seemed like a lot more difficult than that.
So this one is like, I'd say, the first half of it.
Yeah.
It's basically two sides to it. One is straight lines, and then the other is circles.
Yeah.
So we did the straight line stuff, and then started the circle stuff a bit.
Yeah.
And then the other half is circles.
Yeah. The circles bit is the bit that I really struggle on. Definitely.
Okay.
And then triangle geometry as well after that.
So, what do you mean by triangle geometry?
I've got a booklet. It's on our specification, I think. Triangle geometry. I'll try to find that more for you.
Okay, because
I'll send it across.
Okay, and so do you want to do those next? Is it?
Yeah. Finish off coordinate and then move on to that. If that's all right.
So triangle, it's not trig, is it? It's just like geometry.
Yeah. Well, I think so. Yeah, unless because the way that our course works, we get given booklets on different chapters. And the booklet that she gave us at the time is the title of it is Triangle Geometry. So I'll look into it.
So basically, triangles are straight lines, and then the circle geometry would be circles.
Yeah.
If it's trig, then it's just trig. But what we were doing is what you would use for the triangle geometry. This type of thing here, find the area of this triangle. And then we only did a little bit of circles.
Yeah.
But I think it's it. Yeah.
Perfect. Then we'll just do circle geometry.